most of our weather takes place here. So that means most of the water content will be contained within the troposphere. Yes.
Those layers can be destroyed.
It's going to be what?
Can be destroyed from the sun's radiation.
Most of the outer ones.
So we can pretty much go down to the top of the troposphere.
That would take a very, very long time.
So why do they say that just one single layer can just get rid of that? Like a solar array or whatever?
If it was strong enough, it could.
And it's saying it takes so the stronger the are, the easier.
Yeah. Yes.
When I was like looking up information on it, I didn't understand why the temperature decreases as it gets higher when heat rises.
Yeah.
It only go up so far when it's or something.
This is really weird. I don't have an answer for that. It's just one of the things I never quite understood either. Right? Why it does that.
As it travels up, it just loses its heat.
Well,
Space is full. Probably also.
here's the weird thing. Something weird's already happened. When you do lose temperature, as you increase in the troposphere. Alright, I want you guys to understand that, and I'll make a note of that. That as you increase in altitude of the troposphere, your temperature decreases. Okay? And that has a lot to do with the chemistry, as well as the mass of the material. And there's a lot of weird stuff going on. Okay? Now, on the other hand, when we get to the stratosphere, the stratosphere.
What do you mean by something weird about that?
Just look at the fourth bullet underneath stratosphere. As soon as you hit the stratosphere, all of a sudden your temperature now starts to increase with altitude. I don't know. It does. The stratosphere is mostly going to be ozone. That's the most stuff you'll see there. And again, look at how much mass of the atmosphere is located in the stratosphere. What's that number? 20%. How much percentage was in the troposphere?
80.
How much is that total now? So somehow these bottom two layers, I have 100% of my material. Yeah, that's how much little junk is out there as you start moving away from those two layers. Stuff is really far spread out. Okay? Extremely low density.
Is that why it's kind of like, is that what it's really like the oxygen spread out?
Exactly. The farther you get, the less dense that air becomes. You're not having a lot of oxygen. Oxygen is very heavy. It likes to be sucked down near the ground. Not only that, most of our planes cannot fly above the stratosphere. Well, it's the lack of material. The only thing that gives a plane lift is the fact that you have material to fly through. You have fluid. There has to be some friction going on. If you have nothing to fly through, you can't fly. There's nothing to give you lift. So as you start getting into the mesosphere and the thermosphere, there's nothing. There's no material around to actually give you that lift to the plane. So a lot of our planes are stuck in the stratosphere. And we do have some prototypes that can fly up and start getting into the mesosphere, but for the majority, they really cannot handle flying with very little material.
So like you're saying, they made it for the shuttle to go through?
Well, that's the shuttle really can't go through it. It can come back down through it, but it can't go up through it on its own right. That's why it needs the rocket boosters. So again, if you want to think about stratosphere, how many of you guys have ever taken a plane or took a plane ride, going anywhere? Okay, you probably flew through the stratosphere. And if you notice, if you looked up, actually kind of leaned over and looked up the window, what color was the sky? It should have been close to blue or black. Like a very dark, like indigo blue. Very, very dark blue. Alright, that's because at that point, there's hardly any material above you to scatter the sunlight. So therefore you actually get to see space as it is. Which is kind of cool. Oh, come on. Alright, so the next layer, it's called the mesosphere. Meso meaning what? You guys ever heard of a meso? Decreasing again. Huh. Interesting patterns. What do you think is going to happen in the thermosphere? Increase again. And that's again where our auroras do take place. So in your thermosphere is really where we have the ionosphere. And as you can see in this diagram over here, you can see that we have the auroras. So the ionosphere is a piece of the thermosphere. By the way, the thermosphere is the thickest layer. It is the thickest layer of our atmosphere. And we do increase our temperatures with altitude. And some of those temperatures can exceed 1,500 degrees Celsius. That's the ambient temperature. It's a little hot. And then the last one is the exosphere. Basically, there's nothing really going on in the exosphere. Now, Angel, you said something during the research activity. So, our atmosphere never ends? That's correct. There's no clear, defined limit to our atmosphere. It just eventually just keep traveling, and then you're no longer part of Earth's atmosphere. So, in that sense, we would actually say that the atmosphere just continues out forever.
What was after the teacher?
What do you mean?
For the that last one.
Yeah, that was the last one.
Oh, that was the last one.
Now, this is what I was kind of showing you guys before, where we talked about. So in the troposphere, we decrease in altitude. In the stratosphere, we increase, decrease, and increase again through the thermosphere. But now, do you guys see right here, these pauses? What does that tell you right here? What's going on with that temperature? It's staying the same. So I would call it a pause. Okay? It's literally just taking a break for a moment. We're going to stay the same. Now, your altitude will increase, but does the temperature change? So notice I've increased my altitude, but does my temperature change at all? Notice that's what